You're about to hatch from an egg no bigger than a grain of rice, tucked inside a wax cell that your mother built with her own body. The walls around you are paper thin, but they've kept you safe for the past few days while you've been growing. You can't see anything yet, but you can feel the warmth from your siblings pressed against the neighboring cells. Some of them are already moving, pushing against their own walls, trying to break free. Your mother is somewhere above you, crawling across the surface of the nest. She's been working non-stop since she laid your egg, building more cells, gathering food, keeping the temperature just right. She weighs about as much as a paperclip, but she's been carrying loads twice her body weight, back and forth from the flowers outside. Every trip is a gamble with her life, but she doesn't have a choice. You need to eat, and she's the only one who can provide. You push against the wall of your cell, and it gives way slightly. The wax is soft, not like the hard shell of a bird's egg. You push harder, and a small crack appears. Light filters through, the first light you've ever seen. You keep pushing, widening the crack until you can squeeze your head through. Your body follows, and suddenly you're out, lying on the bottom of the cell, breathing air for the first time. You're not much to look at. Your body is pale and soft, like a tiny white grub. You have no wings, no fur, no way to move except to wiggle slightly. Your eyes are just dark spots on your head, and you can barely see shapes and shadows. But you can feel vibrations through the wax, and you know when something is moving nearby. Most importantly, you can feel hunger, a constant gnawing need that will drive everything you do for the next few weeks. Your mother arrives within minutes of your hatching. She's been checking on you regularly, and she knows exactly when you're ready for your first meal. She leans over your cell and opens her mouth, and a drop of clear liquid falls onto your face. It's not milk. Bees don't make milk. It's something else, something she's produced in her own body specifically for you. You open your tiny mouth instinctively, and she feeds you drop by drop. The liquid is rich and sweet, packed with proteins and sugars that your growing body desperately needs. You swallow as much as you can, feeling the warmth spread through your belly. It's not enough. It's never enough. But it's a start. Your mother moves on to the next cell, where another larva is waiting with its mouth open. She'll be back to feed you again in a few hours. But for now, you're on your own. You spend the next few days doing nothing but eating and growing. Your mother brings you food every few hours, and you consume it as fast as she can deliver it. Your body stretches and swells, your pale skin becoming tighter and tighter. You can feel yourself changing, but you don't understand what's happening. All you know is that you're constantly hungry, and the only thing that matters is the next meal. The walls of your cell feel smaller every day. What once seemed like a spacious room now feels cramped and confining. You can barely move without bumping into the sides. Your mother notices this too, and she starts bringing you different food, not just the liquid she's been feeding you, but actual chunks of something solid. It's pollen, mixed with nectar and shaped into small balls. It's harder to swallow than the liquid, but it's more filling, and it helps you grow even faster. After about a week, something strange happens. Your skin starts to feel unbearably tight, like a shirt that's too small. You twist and turn, trying to find a more comfortable position, but nothing helps. The pressure builds until you can't stand it anymore. Then, all at once, your skin splits open along your back. You push and struggle, and the old skin peels away like a discarded sock. Underneath is a new skin, slightly larger and more flexible. You've molted for the first time, and you're officially bigger than you were before. You'll molt several more times over the next few weeks, each time emerging larger and more developed. Your eyes become more complex, able to distinguish between light and dark. Your mouth parts grow stronger, better adapted for chewing solid food. Your body segments become more defined, and tiny buds appear where your legs will eventually grow. But for now, you're still helpless, still completely dependent on your mother for survival. The nest around you is constantly changing. You can hear the vibrations of your mother's footsteps as she walks across the surface, building new cells and repairing old ones. Sometimes you hear other sounds, buzzing that seems to come from far away, or the scraping of something against the outside walls. You don't know what these sounds mean, but they make your mother move faster, more urgently. One day, the vibrations stop. Your mother doesn't come to feed you at her usual time. Hours pass, and still nothing. You're getting hungry, hungrier than you've ever been, but there's nothing you can do except wait. More hours pass. You start to feel weak, your body consuming its own tissues to stay alive. Just when you think you can't take it anymore, you hear footsteps again. But something's different. The rhythm is wrong, the weight distribution not quite right. A face appears above your cell, but it's not your mother. It's another bee, slightly smaller, with different markings on her head. She looks down at you for a moment, then opens her mouth and feeds you the same liquid your mother used to bring. You don't understand what's happened, but you're too hungry to care. You swallow gratefully, feeling strength return to your body. This new bee, your sister, though you don't know it yet, has taken over your mother's job. Your mother is gone, taken by a bird or a spider, or simply worn out from the constant work of keeping the nest alive. Your sister found you and your surviving siblings and made a choice. She could have left you to die and focused on her own survival. Instead, she's decided to sacrifice her own future to keep you alive. She feeds you regularly, just like your mother did, but she's not as experienced. Sometimes she's late with meals, or she brings you the wrong kind of food. You're growing more slowly than you should, and your development is slightly stunted. But you're alive, and that's what matters. Your sister works tirelessly, gathering pollen and nectar from the flowers outside, processing it into food you can digest, and delivering it to you and your siblings multiple times a day. The world outside your cell is dangerous in ways you can't imagine. Every time your sister leaves the nest to gather food, she's risking her life. Birds hunt bees constantly, swooping down from the sky to snatch them out of the air. Spiders wait in flowers, perfectly camouflaged, ready to grab any bee that gets too close. Other insects compete for the same resources, and some of them are bigger and stronger than your sister. But the dangers inside the nest are just as real. Parasites slip through cracks in the walls, looking for larvae to infect. Mites burrow into the wax, weakening the structure of the nest. Wax moths lay their eggs in the comb, and their larvae will eat through the walls of your cell if they get the chance. Your sister does her best to keep these threats at bay, but she's just one bee trying to defend an entire nest. As you grow larger, you become more aware of your surroundings. You can hear the subtle differences in the sounds around you, the gentle scraping of your sister's legs as she builds new comb, the soft buzzing of her wings as she prepares for another foraging trip, the occasional thump of something hitting the outside walls of the nest. You start to understand that you're part of something bigger, a complex system that depends on every member doing their part. Your body continues to change with each molt. Your head becomes more defined, your eyes more complex. Tiny antennae sprout from your forehead, and you can suddenly detect smells and tastes that were invisible to you before. The scent of your sister becomes familiar and comforting. The smell of the wax around you feels like home. But there are other scents too, foreign smells that drift in from outside, reminding you that there's a world beyond your cell. Your legs begin to develop, starting as tiny buds and gradually growing into functional limbs. At first, they're too weak to support your weight, but they grow stronger each day. You start to move around inside your cell, exploring the walls and ceiling with your new appendages. The space that once seemed adequate now feels impossibly small. You're running out of room, and your body is telling you that something needs to change. Your sister notices your increased activity and adjusts your diet accordingly. She brings you more solid food now, chunks of pollen mixed with nectar and formed into nutritious balls. You've learned to chew, and your mandibles are strong enough to break down the tougher textures. Each meal makes you stronger and more restless. You're outgrowing your childhood home, and instinct is telling you that it's almost time to move on to the next stage of your life. The walls of your cell start to feel like a prison. You push against them constantly, testing their strength, looking for weak points, but they're designed to contain you, and they're doing their job well. You're trapped until your body is ready for the next phase of development. Your sister seems to understand this, and she starts visiting you less frequently. She's not abandoning you, she's preparing you for what comes next. One morning, you wake up feeling different. Your body is tingling with a strange energy, and you can't seem to get comfortable no matter how you position yourself. Your skin feels tight again, but this time it's different from the previous molts. This time, something fundamental is changing. You start to produce silk from glands in your head, spinning it into threads that you weave around yourself. Working purely on instinct, you create a cocoon that will protect you during the most vulnerable period of your life. The silk is strong but flexible, allowing you to move slightly while keeping you safe from the outside world. As you spin, you can feel your body beginning to change in ways you've never experienced before. Your muscles are restructuring themselves, your organs are shifting position, and new structures are forming beneath your skin. The cocoon seals shut around you, and suddenly you're in complete darkness. You can't see, can't hear, can't even move very much, but you can feel the transformation happening inside you. Your larval body is being broken down and rebuilt from the ground up. Wings are forming along your back, compound eyes are developing in your head, and your digestive system is being completely reorganized. You're becoming something entirely new, something that will be able to survive in the world outside your cell. The process takes about 2 weeks, though you have no way to measure time in your dark cocoon. You drift in and out of consciousness, your body using every bit of energy to fuel the transformation. Sometimes you dream of flying, though you've never seen the sky. Sometimes you dream of flowers, though you've never seen colors. Your developing brain is preparing you for a life you can't yet imagine. When you finally emerge from your cocoon, you're no longer the helpless larva you once were. You're a fully formed adult bee with wings, antennae, and compound eyes that can see the world in ways your larval brain never could. Your first breath of air through your new respiratory system is a revelation. Your first glimpse of light through your compound eyes shows you a world of incredible complexity and beauty. But you're still weak from the transformation, and your wings are soft and folded against your body. You need time to dry and harden before you can take your first flight. Your sister is there waiting for you, and she recognizes you despite your completely changed appearance. She feeds you honey, rich and sweet, giving you the energy you need to complete your development. Over the next few hours, your wings expand and harden, your exoskeleton becomes stronger, and your muscles develop the power they'll need to carry you through the air. You test your wings tentatively, feeling the air move beneath them. The sensation is completely foreign, but somehow you know exactly what to do. Flight is programmed into your genes, and your body remembers what your mind has never learned. Your first flight is nothing like you imagined. You launch yourself from the edge of your cell, wings beating frantically, and immediately crash into the wall of the nest. The impact stuns you, and you tumble to the bottom, legs tangled beneath you. Your sister watches without intervening. This is something you have to figure out on your own. You try again, this time focusing on the rhythm of your wing beats. Your wings move so fast they're almost invisible, creating a high-pitched buzz that fills the air around you. You manage to hover for a few seconds before losing control and spinning sideways into another wall. It's humiliating, but you keep trying. Each attempt teaches you something new about balance, about the relationship between your wings and your body, about the invisible currents of air that can either lift you up or knock you down. After dozens of crashes, something clicks. You lift off smoothly, hover in place for several seconds, then move forward in a controlled line. It's not graceful, but it's flight. Your sister buzzes her approval, a sound you've never heard before, but somehow understand. You're finally ready to see the world beyond your nest. The entrance to your nest is a small hole in the side of a wooden structure, barely large enough for a bee to pass through. As you approach it, you can see light streaming in from outside, not the dim, filtered light of your cell, but bright, intense illumination that makes your compound eyes water. The air moving through the entrance carries a sense you've never encountered before. Flowers, earth, other animals, and something else, something vast and open that calls to every instinct in your body. Your sister goes first, disappearing through the hole in an instant. You hesitate at the threshold, suddenly terrified of what lies beyond. Everything you've ever known is behind you, but everything you need to survive is ahead. You take a deep breath and plunge through the opening. The world explodes around you in a chaos of color, sound, and movement. The sky stretches endlessly above you, a brilliant blue dome that seems to go on forever. Below, the ground is covered in green plants that wave in the breeze, dotted with bright patches of color that your brain identifies as flowers. The air is full of scents so complex and layered that your antennae can barely process them all. But it's the space that overwhelms you most. After weeks of being confined to a tiny cell, the sheer vastness of the outside world is almost paralyzing. You can fly in any direction, as far as your wings can carry you, and there's nothing to stop you. The freedom is intoxicating and terrifying at the same time. Your sister is waiting for you, hovering near a cluster of yellow flowers, about 20 feet from the nest. She's not just showing you where to go, she's teaching you how to navigate. You follow her, struggling to maintain altitude in the shifting air currents. Flying outside is completely different from flying inside the nest. The wind pushes you around, thermals lift you unexpectedly, and you have to constantly adjust your wing speed and angle to stay on course. The flowers are your first real destination, and they're unlike anything you've ever imagined. Each bloom is a complex structure of petals, stamens, and pistils, all arranged in patterns that seem designed specifically for bees. The colors are intense, yellows and blues and purples that make your eyes ache with their brightness. But it's the scent that really gets your attention. These flowers are advertising themselves to you, sending out chemical signals that say food here in a language your brain understands instinctively. You land on your first flower, legs gripping the soft petals as you lower your head toward the center. Your proboscis, a long tube-like tongue that you didn't even know you had, extends automatically, probing deep into the flower's core. The nectar you find there is unlike anything you've tasted before. It's sweet and complex, with flavors that seem to change as you drink. This is what you were born for. This is what your entire body is designed to do. But you're not alone on this flower. As you drink, you notice movement around you, other insects competing for the same resource. A butterfly lands nearby, its massive wings making you look tiny by comparison. It has the same idea you do, and it's not interested in sharing. You buzz a warning, but the butterfly ignores you, moving closer to the nectar source. This is your first real conflict, and you're not sure how to handle it. Your sister is nearby, but she's busy with her own flower. You're going to have to figure this out yourself. The butterfly is bigger than you, but you're faster and more maneuverable. You launch yourself at it, not to attack, but to intimidate. Your buzzing gets louder, more aggressive. The butterfly gets the message and flutters away to find another flower. You return to your nectar, but the encounter has taught you something important. Resources are limited, and you're going to have to fight for them. Every flower, every drop of nectar, every grain of pollen is contested territory. You're not just foraging, you're competing in a complex ecosystem where everyone is trying to survive. Your sister shows you how to collect pollen, brushing it from the flower's stamens onto the specialized hairs on your legs. The pollen sticks to you like tiny golden dust, accumulating in thick clumps that you'll carry back to the nest. It's protein-rich food that will feed the next generation of larvae, but it's also heavy. As your pollen baskets fill up, flying becomes more difficult. You have to work harder to stay airborne, and your range becomes limited. The trip back to the nest is your first real test as a forager. You're loaded down with nectar and pollen, flying low and slow, vulnerable to every predator in the area. Your sister leads the way, but she can't protect you from everything. A bird swoops overhead, and you dive toward the ground, hiding among the leaves until it passes. A spider sits motionless in its web, almost invisible until you're close enough to see its eyes tracking your movement. You make it back to the nest safely, but barely. Your legs are shaking from the effort, and your wings feel like they're about to give out. But you've done it. You've completed your first foraging run, and you're starting to understand what your life is going to be like. It's dangerous, exhausting work, but it's also essential. Without bees like you, the flowers wouldn't get pollinated, and the world would be a very different place. Inside the nest, you unload your cargo, regurgitating the nectar into storage cells and scraping the pollen from your legs. Other bees take over from there, processing the raw materials into honey and bee bread, concentrated foods that will sustain the colony through hard times. You're just one small part of a much larger operation, but your contribution matters. Over the next few weeks, you establish a routine. You wake up before dawn, spend the day foraging, and return to the nest exhausted but satisfied. You learn to read the landscape, memorizing the locations of the best flowers and the safest routes between them. You develop preferences, certain flowers that taste better, certain times of day when the nectar flow is strongest, certain weather conditions that make flying easier. You also learn about danger. One morning, you arrive at your favorite patch of flowers to find them covered in a fine white powder. The scent is wrong, chemical and artificial instead of the natural fragrances you're used to. Your sister lands beside you and immediately takes off again, buzzing frantically. You follow her instincts and avoid the flowers, but later you see other bees who weren't so lucky. They're moving slowly, erratically, their nervous systems disrupted by whatever poison humans have sprayed on the plants. The world is full of these invisible threats. Pesticides kill you slowly, disrupting your ability to navigate and remember. Herbicides eliminate the plants you depend on for food. Climate change shifts the timing of flower blooms, leaving you scrambling to find nectar when you need it most. Habitat destruction wipes out entire ecosystems, forcing you to travel farther and farther to find adequate foraging grounds. But you adapt because you have to. You find new flowers, learn new routes, adjust your schedule to match the changing seasons. Your brain, despite being smaller than a sesame seed, is capable of remarkable feats of memory and navigation. You can remember the locations of hundreds of flowers, calculate the most efficient routes between them, and even communicate this information to other bees through a complex dance language. The dance is how you share information with your nestmates. When you find a particularly rich source of nectar, you return to the nest and perform a figure-8 pattern on the vertical surface of the comb. The angle of your dance relative to vertical indicates the direction of the flowers relative to the sun. The duration of your waggle run tells other bees how far away the flowers are. The intensity of your buzzing and the samples of nectar you share convince them that the trip is worth making. It's a sophisticated communication system that allows your small colony to exploit resources across a huge area. When you dance, dozens of other bees pay attention, memorizing the details of your performance. Within hours, a stream of foragers will be visiting the flowers you discovered, each one collecting nectar and pollen to bring back to the nest. Your colony is growing. The queen, whom you've never actually seen, is laying eggs constantly, and new workers are emerging from their cells every day. The nest is expanding, with new comb being built to accommodate the growing population. You're part of a superorganism now, a collective entity that's much more than the sum of its parts. But success brings its own problems. A larger colony needs more resources, and you're having to fly farther and farther to find adequate supplies. Competition with other colonies is intensifying, and you sometimes encounter bees from neighboring nests at the same flowers. These encounters are usually peaceful. There's enough nectar for everyone, but sometimes tensions flare, and you find yourself in aerial combat with bees who look almost identical to you. The days are getting shorter, and the flowers are becoming less abundant. You can feel change in the air, a subtle shift in temperature and humidity that triggers something deep in your genetic programming. Your body is starting to slow down, your flights becoming less frequent and less productive. You're not sick, you're just getting old. For a worker bee, old age comes quickly. You've been alive for only a few months, but in bee terms, that's a full lifetime. Your wings are becoming frayed from constant use. Your body is wearing out from the relentless demands of foraging, and your ability to navigate is starting to decline. You're becoming less efficient, less reliable, less valuable to the colony. One morning, you wake up feeling different. Your wings are too damaged to carry you very far, and your legs can barely support your weight. You try to leave the nest for another foraging run, but you only make it a few feet before you have to land. Your flying days are over. You drag yourself back inside the nest, your wings scraping against the entrance as you struggle to fit through. The other bees barely notice you. They're too busy with their own tasks, building comb, processing nectar, tending to larvae. You're just another aging worker, and there are dozens of younger, stronger bees ready to take your place. But you're not ready to give up yet. If you can't forage, you can still contribute in other ways. You make your way to the brood area, where the newest larvae are developing in their cells. Your body may be failing, but your knowledge is still valuable. You can help tend the young, sharing the warmth of your body to keep them at the right temperature. A young bee approaches you, newly emerged from her cell. She's confused and disoriented, her wings still soft and her movements uncertain. You recognize the signs. You were in her position not so long ago. Without thinking, you guide her toward the honey stores, showing her how to feed herself properly. She follows your lead, learning from your experience. This is your new role now. You're no longer a forager, you're a nurse bee, one of the older workers who stays inside the nest to care for the next generation. It's less glamorous than flying through fields of flowers, but it's just as important. The larvae need constant attention, and without experienced bees like you, many of them wouldn't survive. You check on a group of young larvae, their pale bodies writhing in their cells. They're hungry, as always, and you regurgitate some of the honey you've stored in your crop. The liquid is rich and nutritious, exactly what they need to fuel their rapid growth. You move from cell to cell, feeding each larva in turn, monitoring their development with the expertise that comes from experience. The work is exhausting, but there's something satisfying about it. You're directly contributing to the future of the colony, ensuring that the next generation will be strong and healthy. Every larva you feed is a potential forager, a potential queen, a potential founder of a new colony. Your individual life may be ending, but your contribution to the species will continue. Days pass in a blur of routine. You wake up, tend to the larvae, help with comb construction, and share information with the younger bees. Your body continues to deteriorate. Your antennae are less sensitive. Your legs are weaker. Your movements are slower. But your mind remains sharp, and you use your accumulated knowledge to help the colony function more efficiently. One afternoon, you notice something unusual. The queen's pheromones are different, weaker, less pervasive. The chemical signals that normally keep the colony united and focused are becoming erratic. You can sense the other bees' confusion, their growing agitation. Something is wrong with the queen, and that means something is wrong with the entire colony. The younger bees don't understand what's happening. They've never experienced a queen's decline, never seen a colony lose its central organizing force. But you have the experience to recognize the signs. The queen is aging just like you, and her ability to lay eggs and produce pheromones is failing. The colony is entering a crisis. Without strong pheromone signals, the workers become restless and disorganized. Some of them start laying their own eggs, even though they're not fertile. Others begin fighting among themselves, competing for resources that were once shared freely. The careful social structure that held the colony together is beginning to break down. You try to maintain order in your small section of the nest, but it's a losing battle. The chaos is spreading, and there's nothing you can do to stop it. The younger bees are panicking, flying in circles, abandoning their posts. The larvae are being neglected, their food supplies running low, the colony is collapsing from within. Then, one morning, you wake up to find something unexpected. In a special cell, larger than the others, a new queen is developing. The workers have been feeding her royal jelly, a special secretion that triggers the genetic changes necessary for her to become reproductively capable. She's your colony's last hope, the potential savior who could restore order and stability. But raising a new queen is dangerous. If she emerges while the old queen is still alive, there will be a fight to the death. Only one queen can rule a colony, and they will battle until one of them is dead. The timing has to be perfect. The new queen must emerge, just as the old queen's strength fails completely. You watch over the developing queen with special care, monitoring her progress, ensuring she gets the nutrition she needs. Her cell is larger than a normal worker cell, and her development is taking longer. She's growing into something fundamentally different from you, larger, stronger, with reproductive organs that will allow her to lay thousands of eggs. The old queen's condition continues to deteriorate. Her egg laying has nearly stopped, and her pheromone production is sporadic. The colony is holding its breath, waiting for the moment when leadership will change hands. You can feel the tension in the air, the anticipation that something momentous is about to happen. Then, one day, the new queen begins to emerge. You can hear her through the walls of her cell, a distinctive piping sound that no worker ever makes. It's a royal sound, a declaration of her status and power. The old queen responds with her own piping, weaker but still defiant. The battle for control is about to begin. The new queen breaks free from her cell, her body gleaming and perfect. She's larger than any worker, with a long, curved abdomen and powerful wings. But she's also inexperienced, untested in the harsh realities of colony management. She looks around the nest with compound eyes that have never seen the outside world, trying to understand her new domain. The old queen moves to confront her, despite her weakened condition. The two queens circle each other, their antennae twitching, their bodies tense with aggression. This is an ancient ritual, as old as bee society itself. Only one will survive, and the winner will determine the colony's future. The battle is brief, but vicious. The queens grapple with each other, their stingers seeking vulnerable spots in each other's armor. You watch from a safe distance, knowing that interfering would mean death. This is not your fight. It's a contest between royalty, and workers are not allowed to participate. The old queen fights bravely, but she's too weak to match her younger opponent. The new queen's stinger finds its mark, and the old queen collapses, her body twitching as the venom takes effect. The colony's founder, the mother of thousands of workers, dies on the floor of her own nest. The new queen stands over her predecessor's body, victorious but uncertain. She's won the right to rule, but she doesn't yet know how to exercise that power. The workers around her are confused, their loyalty torn between the dead queen they've served and the living one who now commands them. Gradually, the new queen begins to assert her authority. Her pheromones start to fill the nest, different from the old queen's but equally powerful. The workers respond instinctively, their behavior changing to accommodate their new ruler. The chaos begins to subside, replaced by a new kind of order. But the new queen faces enormous challenges. The colony is weakened, its population reduced, its resources depleted. She needs to start laying eggs immediately to rebuild the workforce, but she's never mated. She's still a virgin queen, and without mating, she can't produce the fertilized eggs that will become new workers. The queen prepares for her nuptial flight, the most dangerous journey of her life. She must leave the safety of the nest, fly to a distant location where male bees are waiting, mate with multiple partners, and return home safely. It's a gauntlet of predators and hazards, and many young queens don't survive the attempt. You watch her preparations with a mixture of admiration and concern. She's checking her wings, testing her flight muscles, preparing for the journey that will determine the colony's fate. If she succeeds, the nest will be reborn. If she fails, everything you've worked for will die with her. The morning of her flight arrives clear and calm. The queen positions herself at the entrance to the nest, her wings catching the early sunlight. She's beautiful and terrifying, a perfect example of evolutionary engineering. Every part of her body is designed for one purpose: to perpetuate the species. She launches herself into the air, her wings beating with a deep, powerful rhythm. You can track her progress for a few moments as she circles the nest, gaining altitude and speed. Then she disappears over the horizon, carrying the future of the colony with her. The hours that follow are the longest of your life. The workers go about their tasks mechanically, but everyone is listening for the sound of returning wings. If the queen doesn't come back, the colony will slowly die. Without new workers to replace the aging ones, the nest will eventually become empty and silent. Late in the afternoon, you hear it, the distinctive buzz of royal wings. The queen has returned, and she's not alone. A small group of male bees follows her, though they won't be allowed inside the nest. They've served their purpose, and their lives are forfeit. The queen carries their genetic material inside her body, stored in a special organ that will allow her to fertilize eggs for the rest of her life. The queen enters the nest transformed. She's no longer a virgin, but a true reproductive queen, capable of laying thousands of eggs. Her pheromones are stronger now, more complex, carrying the chemical signature of successful mating. The workers respond immediately, their behavior shifting to accommodate their newly fertile ruler. Within days, the queen begins laying eggs at an incredible rate. She moves through the nest methodically, inspecting each empty cell, depositing a single white egg in the center. The eggs are tiny, barely visible, but each one represents the potential for new life. The colony's renaissance has begun. You help tend the new eggs, keeping them warm and humid, monitoring their development. Your body is failing more rapidly now, your movements becoming increasingly labored. But you're determined to see at least some of these eggs hatch, to witness the next generation that will carry on the colony's work. The first eggs begin to hatch after 3 days. Tiny larvae emerge, pale and helpless, their mouths open and ready for food. You feed them with the last of your strength, regurgitating honey and pollen to fuel their growth. Each larva you feed is a small victory, a contribution to the colony's future. More eggs hatch every day, and the nest begins to fill with the sounds of new life. The queen continues laying, her production increasing as her confidence grows. The workers are busy again, building new comb, processing food, caring for the rapidly growing brood. The colony is recovering, rebuilding itself from near extinction. But you're not going to be part of the recovery. Your body is shutting down, your systems failing one by one. Your wings are useless now, your legs barely able to support your weight. You can feel death approaching, not as a sudden event, but as a gradual fading of life force. You make your way to a quiet corner of the nest, away from the busy areas where the younger bees are working. This is where old bees come to die, a place where your body won't interfere with the colony's operations. You've seen other bees make this journey, and now it's your turn. You settle into a small crevice between 2 pieces of comb, your body finally still after months of constant motion. Your compound eyes are dimming, your antennae no longer sensitive to the chemical signals that once guided your every action. But you can still hear the sounds of the nest around you, the buzzing of wings, the scraping of legs on wax, the quiet hum of a thriving colony. The sounds are comforting, a reminder that your life had meaning. You helped build this nest, fed these larvae, contributed to the great work of the colony. Your individual existence may be ending, but the colony will continue. The eggs you helped tend will hatch, the larvae will grow, and new foragers will take your place in the fields. Your breathing becomes shallow, your heartbeat irregular. The world around you is fading, but you're not afraid. Death is just another part of the cycle, as natural as molting or metamorphosis. You've lived a full life by bee standards, contributed to something larger than yourself, and played your part in the endless dance of survival and reproduction. As consciousness slips away, you can still hear the queen moving through the nest, laying eggs, rebuilding the colony. The sound of her footsteps on the comb is steady and purposeful, a rhythm that will continue long after you're gone. The colony will survive, thrive, and eventually send out new queens to start colonies of their own. Your body goes still, but your contribution lives on in the structure of the nest, in the knowledge you passed to younger bees, in the larvae you helped raise. You were just one bee among thousands, but you were essential. The colony couldn't have survived without you, and it won't survive without the countless other bees who will follow in your footsteps. The other workers will find your body eventually and carry it outside, away from the nest. It's a final act of hygiene, ensuring that the colony remains clean and healthy. Your death will barely register in the grand scheme of things, just another worker at the end of her useful life. But for a brief moment, you were part of something magnificent. You flew through fields of flowers, danced to communicate with your sisters, helped raise the next generation, and contributed to the survival of your species. Your life was short by human standards, but it was complete. You did everything a bee was meant to do. The nest continues its work around your empty space. New bees emerge from their cells, take their first flights, and begin the same cycle you just completed. The colony is eternal, even though its individual members are temporary. This is the paradox of social insects. The individual dies, but the society lives on. Your story is over, but the story of your colony continues. The queen you helped protect will lay millions of eggs, creating generations of workers who will carry on the essential work of pollination. The flowers you visited will bloom again, fed by the nutrients your body eventually provides to the soil. The cycle continues, endless and beautiful, a testament to the power of cooperation and the resilience of life. Life as a worker bee doesn't end with death, not when you're part of something bigger than yourself. The colony's rhythm continues, and within hours of your passing, a new worker emerges from her cell to take your place. She doesn't know about you, doesn't understand that she's filling a gap left by your absence. To her, this is simply the beginning of her own story, but the colony remembers in its own way. The comb you helped build still stands strong. The larvae you fed have grown into capable workers. The roots you discovered through your tireless foraging are still being used by bees who learned from your dances. Your individual life may have ended, but your influence ripples through the generations. The new queen continues her relentless egg-laying, and the nest grows larger every day. Fresh comb appears in sections you never saw, built by workers who were just eggs when you died. The population swells, and the colony's influence spreads across a wider territory. Your death was just one small moment in this explosion of life. Spring arrives with a burst of activity that would have thrilled you. The first flowers bloom earlier than expected, and the entire colony mobilizes to take advantage of the bonanza. Young foragers, their wings still pristine and their bodies strong, venture out in numbers you could never have imagined. They return loaded with nectar and pollen, their cargo holds bulging with the wealth of the season. The queen responds to the abundance by increasing her egg production even further. She moves through the nest like a living factory, depositing eggs at a rate that seems impossible. Each cell receives its precious cargo, and within days, the nest is buzzing with the activity of thousands of developing larvae. The colony is entering its golden age. But success brings new challenges. The nest is becoming crowded, and space is running out. The workers are building new comb as fast as they can, but they can't keep up with the queen's productivity. Tension builds in the air, a restlessness that spreads through the colony like a contagion. Something has to give. The workers begin preparing for the inevitable. In several special cells, they start raising new queens. These aren't replacements for the current queen. They're potential founders of new colonies. The process is careful and deliberate, with selected larvae receiving the royal jelly treatment that will transform them into reproductive individuals. The current queen senses what's happening and becomes agitated. Her pheromone production increases, flooding the nest with chemical signals that demand loyalty and obedience. But the workers are driven by instincts older than individual preference. The colony is ready to divide, and nothing can stop the process now. One by one, the new queens begin to emerge from their cells. But this time, something different happens. Instead of fighting to the death, the original queen makes a choice that will echo through bee history. She gathers a portion of the workers around her and prepares to leave. This is swarming, the colony's method of reproduction. The swarm builds slowly, with more and more workers joining the queen's entourage. They gorge themselves on honey, storing energy for the journey ahead. Their abdomens swell with the liquid fuel that will sustain them while they search for a new home. The atmosphere in the nest becomes electric with anticipation. When the moment arrives, it happens all at once. The queen launches herself from the entrance, and thousands of workers follow. They pour out of the nest like a living river, their wings creating a sound like thunder. The sky fills with bees, a massive cloud of insects moving with single-minded purpose. The swarm doesn't go far at first. They cluster on a nearby tree branch, forming a dense ball of bodies with the queen at the center. Scout bees immediately disperse in all directions, searching for suitable locations for a new nest. They need a cavity that's the right size, with good ventilation and protection from the elements. For hours, the swarm hangs motionless while the scouts do their work. The bees on the outside of the cluster spread their wings and fan their sisters, keeping the queen cool and comfortable. Those on the inside generate heat, maintaining the perfect temperature for the group's survival. It's a remarkable display of cooperation and organization. The scouts return with reports of potential nest sites. They communicate their findings through the same dance language you once used, but now they're advertising real estate instead of flowers. The better the site, the more enthusiastic the dance. Gradually, consensus builds around the best option. When the decision is made, the swarm takes flight again. This time, their destination is clear, a hollow tree several miles away, with a narrow entrance and plenty of internal space. The journey is dangerous, with the swarm vulnerable to birds and weather. But they make it safely, settling into their new home like colonists claiming virgin territory. Meanwhile, back at the original nest, a new queen has taken control. She's younger and stronger than her predecessor, with a different genetic makeup that will influence the colony's future behavior. Her first task is to deal with any remaining virgin queens. She hunts them down one by one, eliminating potential rivals with ruthless efficiency. Once her dominance is established, the new queen begins her own nuptial flight. Like her predecessor, she must mate with multiple males to ensure genetic diversity in her offspring. The flight is successful, and she returns to begin laying eggs in the cells vacated by the swarm. Both colonies, the original and the new, face uncertain futures. The swarm must build everything from scratch: comb, food stores, brood cells. They work frantically, knowing that winter is only months away. Every day counts, and there's no room for error. The original colony has infrastructure but reduced numbers. The workers who remained must rebuild their population while maintaining the existing nest. It's a different challenge, but equally demanding. Both groups are racing against time and the changing seasons. As summer progresses, both colonies establish their rhythms. The swarm's new nest grows rapidly, with fresh white comb appearing daily. Their foraging flights become more organized as they learn the local flower patterns. The original colony, meanwhile, focuses on raising new workers to replace those who left with the swarm. The genetic legacy you helped preserve continues to spread. Your queen's offspring are now scattered across 2 colonies, each carrying pieces of the DNA that once flowed through your own body. The traits that made you a successful forager, your navigation skills, your flower preferences, your work ethic, live on in these new generations. But nature is never predictable, and challenges arise that test both colonies' resilience. A late summer drought reduces nectar production across the region. Flowers that should be blooming are withered and dry. Competition for the remaining resources becomes fierce, with multiple species fighting for access to the few productive patches. The new colony, with its smaller stores and less established foraging network, struggles more than its parent. Their scouts range farther and farther from the nest, desperately searching for sources of nectar and pollen. Some don't return, casualties of the harsh conditions and increased predation that comes with longer flights. The original colony fares better, thanks to its established territory and deeper honey reserves. But even they feel the pressure. Foraging flights that once brought back full loads now return with barely enough to justify the energy expenditure. The queen reduces her egg laying as food becomes scarce. Then, just when things seem hopeless, the rains return. The delayed moisture triggers a second bloom in many flowers, creating an unexpected bonanza. Both colonies mobilize every available forager, working from dawn to dusk to take advantage of the windfall. It's a reminder of how quickly fortune can change in the natural world. The autumn preparations begin earlier than usual after the summer's scares. Both colonies work furiously to build up their honey stores before the final flowers fade. Every cell that isn't occupied by brood gets filled with the concentrated nectar that will sustain them through winter. The race against time is on. As the days grow shorter and temperatures drop, the colonies enter survival mode. The queens stop laying eggs, and the workers cluster together for warmth. The endless activity of summer gives way to the quiet endurance of winter. Most of the colony goes dormant, conserving energy for the long months ahead. But life continues even in dormancy. The workers take turns moving to the outside of the cluster, sacrificing their warmth for the good of the group. The queen remains at the center, protected and cherished, her survival essential for the colony's future. This is the ultimate expression of the cooperative spirit that once drove your own actions. The original colony, with its larger population and better established stores, weathers the winter successfully. When spring arrives, they're ready to explode back into activity. The queen begins laying again, and the cycle of growth and expansion resumes. They're stronger than ever, having proven their resilience in the face of adversity. The swarm's colony faces a harder test. Their smaller numbers and limited reserves are pushed to the breaking point by an unusually harsh winter. Some workers don't survive the cold, their bodies found frozen on the floor of the nest when spring finally arrives. But the core of the colony endures, and the queen is still alive and healthy. When the first flowers bloom, both colonies emerge from their winter refuges like survivors of a siege. They're thinner, more cautious, but alive. The successful overwintering is a testament to the wisdom embedded in their social structure, the same structure you helped maintain during your brief but essential life. The cycle begins anew with the spring buildup. Young workers emerge from their cells with the same wonder and determination you once felt. They take their first flights, discover their first flowers, and begin contributing to the endless work of the colony. Your genetic legacy flows through their veins, influencing their behavior in ways they'll never understand. As the seasons turn and years pass, your influence spreads further. The colonies you helped establish send out their own swarms, creating new settlements across the landscape. Each new colony carries forward the traits and behaviors that made the original successful. Your individual death was just one moment in this expanding web of life. The flowers you once visited continue to bloom, year after year, benefiting from the pollination services provided by your descendants. The ecosystems you helped maintain flourish and evolve, supporting countless other species that depend on the complex relationships between plants and their pollinators. Your work continues long after your death, but perhaps the most remarkable legacy is the one that can't be seen or measured. The knowledge you accumulated during your short life, the flower locations, the weather patterns, the optimal foraging strategies, was passed on to other bees through your dances and interactions. That information became part of the colony's collective memory, influencing decisions for generations to come. New challenges continue to emerge as the world changes around your descendants. Pesticides appear in their environment, disrupting their nervous systems and navigation abilities. Habitat destruction eliminates familiar foraging grounds, forcing them to adapt to new landscapes. Climate change alters flowering schedules and weather patterns, making survival increasingly difficult. But bees are remarkably adaptable, and your genetic legacy includes the flexibility that allows them to respond to new threats. Some colonies develop resistance to certain pesticides. Others learn to exploit new food sources as traditional ones disappear. The same intelligence that guided your own foraging flights helps your descendants navigate an increasingly complex world. The social bonds that sustained your colony continue to evolve and strengthen. New forms of communication develop, allowing more precise information sharing about distant food sources. Construction techniques improve, creating more efficient nest designs. The cooperative spirit that defined your life finds new expressions in each generation. Your story, brief as it was, represents something profound about the nature of life itself. You were born into a world you didn't choose, faced challenges you didn't anticipate, and made contributions you couldn't fully understand. Yet every action you took, every flower you visited, every dance you performed, added to something larger than yourself. The colony you served continues to thrive, not because any individual bee is irreplaceable, but because each one contributes something essential to the whole. Your pollination services helped plants reproduce. Your nest-building efforts provided shelter for thousands of developing young. Your foraging knowledge helped the colony exploit its environment more efficiently. The endless cycle of life and death, growth and reproduction, cooperation and competition that you experienced continues across the landscape. Millions of bees live out their own brief stories, each one as complete and meaningful as yours. Together, they form a living network that connects flowers and forests, gardens and wild spaces, maintaining the delicate balance that keeps ecosystems functioning. In the end, your life as a worker bee was exactly what evolution designed it to be: short, intense, and utterly devoted to the survival of something greater than yourself. You experienced the full range of a bee's existence, from helpless larva to skilled forager to aging nurse, and played each role with the dedication that characterizes your species. The nest you helped build may eventually crumble, the queen you served may die, and the specific colony you knew may fade into history. But the genetic information you carried, the behaviors you exhibited, and the contributions you made will ripple forward through time, influencing countless future generations of bees. Your individual consciousness may have ended, but your impact continues. Every flower that blooms thanks to pollination by your descendants, every new colony that thrives using strategies perfected in your nest, every ecosystem that remains stable because of ongoing bee activity, all of these bear traces of your influence. The morning sun that once called you to your first foraging flight continues to rise over fields of flowers. The nectar that sustained you continues to flow in countless blossoms. The dance floor where you once shared your discoveries continues to host new performances by new dancers. The great work goes on, as it always has, as it always will. Your complete life as a worker bee, from the moment you hatched to your final breath, was a perfect expression of what it means to be part of something larger than yourself. You lived fully, worked tirelessly, and contributed meaningfully to the ongoing story of life on Earth. In the vast tapestry of existence, your thread was small but essential, adding its own unique color to the beautiful, complex pattern that connects all living things. The seasons blur together as your descendants face an increasingly hostile world. A new threat emerges that you never encountered: parasites smaller than dust mites that burrow into developing larvae. They arrive without warning, carried by wind and rain, infiltrating colonies through cracks too small for bees to detect. The infected larvae develop normally at first, but something is wrong beneath the surface. These parasites multiply inside the growing bees, weakening their immune systems and disrupting their development. Workers emerge from their cells, looking healthy but carrying invisible damage. Their wings don't fold properly, their navigation systems malfunction, and their lifespans are cut in half. Entire colonies collapse within months, their populations crashing as the parasites spread through the brood. Your genetic line faces this new challenge with the same resilience that carried you through your own struggles. Some colonies develop behavioral defenses, workers who can detect infected cells and remove the compromised larvae before the parasites mature. Others evolve physiological resistance, their immune systems learning to recognize and fight the invaders. But adaptation takes time, and many colonies don't survive long enough to develop effective defenses. The landscape becomes dotted with empty nests, their silent combs serving as monuments to failed communities. The survivors cluster in isolated pockets, rebuilding slowly while the parasites search for new hosts. Climate patterns shift dramatically as decades pass. Storms arrive with unprecedented fury, flooding nests and scattering swarms. Droughts last longer than any bee alive can remember, withering flowers across entire regions. The reliable seasonal rhythms that once guided foraging schedules become chaotic and unpredictable. Your descendants learn to read new signs in the environment. They watch cloud formations more carefully, sensing pressure changes that might indicate approaching weather. They develop more flexible foraging strategies, switching rapidly between different flower types as availability fluctuates. The rigid specialization that once defined colony roles gives way to adaptability and quick thinking. Some colonies develop nomadic tendencies, moving their entire operation when local conditions become unsuitable. They carry their young in carefully constructed portable cells, abandoning permanent structures in favor of mobility. It's a radical departure from traditional bee society, but it works in an unstable world. The flowers themselves are changing too. Plants that once provided reliable nectar sources evolve new defensive chemicals to protect against increased herbivore pressure. Some flowers become toxic to bees, their bright colors hiding deadly alkaloids. Others reduce their nectar production, forcing pollinators to work harder for the same rewards. But new opportunities emerge as well. Introduced plant species from distant continents offer novel food sources with different blooming schedules. Urban environments create microclimates that extend flowering seasons. Human gardens, despite their artificial nature, sometimes provide more reliable resources than degraded natural habitats. Your descendants learn to exploit these new niches with characteristic bee ingenuity. They develop preferences for non-native flowers that their ancestors never encountered. They establish roots through city parks and suburban gardens, navigating by landmarks that didn't exist in your time. The ancient art of bee navigation adapts to modern landscapes. Communication systems evolve to handle increasingly complex information. The traditional dance language expands to include warnings about contaminated flowers, updates on rapidly changing weather conditions, and detailed reports about new food sources. The social intelligence that once helped your colony coordinate simple foraging operations now manages intricate networks of information sharing. Predator populations fluctuate wildly as ecosystems destabilize. Bird species that once provided predictable threats disappear from some regions while exploding in others. New predators arrive, invasive species with no natural controls, hunting bees with unfamiliar strategies. The constant vigilance that characterized your own foraging flights becomes even more critical for survival. But your descendants also benefit from unexpected allies. Some bird species develop mutualistic relationships with bee colonies, defending nest sites in exchange for access to bee-killed insects. Certain spider species learn to hunt bee predators rather than bees themselves, creating protective zones around active foraging areas. The genetic diversity preserved in your original colony becomes crucial for survival in this changing world. Traits that seemed unimportant in your time, unusual temperature tolerance, resistance to specific toxins, alternative navigation strategies, prove essential as conditions shift. The random genetic recombination that occurs with each generation creates new combinations of survival traits. Queen breeding becomes more strategic as colonies recognize the importance of genetic flexibility. Instead of simply replacing failing queens, successful colonies begin maintaining multiple egg-laying females, each contributing different genetic lines to the population. It's a risky strategy that requires careful resource management, but it provides insurance against unpredictable threats. The timing of swarm production shifts to match new environmental rhythms. Colonies that once swarmed predictably in late spring now send out reproductive groups whenever conditions seem favorable. Multiple small swarms replace single large ones, spreading risk across different locations and seasons. Some swarms travel unprecedented distances, following new migration routes that span continents. They ride air currents that didn't exist in your time, navigating by magnetic fields disrupted by human technology. The pioneering spirit that drove your own first flights outside the nest finds expression in these epic journeys. Urban colonies develop entirely new architectural styles, building nests in artificial cavities that would have seemed impossible to your generation. They learn to work with human-made materials, incorporating synthetic fibers and chemical residues into their construction. The traditional wax comb gives way to hybrid structures that blend natural and artificial elements. These city-dwelling bees face unique challenges that rural colonies never encounter. Light pollution disrupts their circadian rhythms, making it difficult to time foraging flights. Air pollution coats their bodies with particles that interfere with chemical communication. Noise pollution masks the subtle vibrations they use for navigation and coordination. Yet urban bees also discover advantages unavailable to their country cousins. Heat islands, created by pavement and buildings, extend their active season. Diverse landscaping provides resources throughout the year. Human activities create windbreaks and sheltered microclimates that protect against extreme weather. The social structures that defined your colony continue to evolve under these new pressures. Traditional caste systems become more fluid as workers take on multiple roles throughout their lives. Queens develop new strategies for managing diverse populations spread across fragmented territories. The rigid hierarchies that once maintained order give way to more flexible networks of cooperation. Communication between distant colony fragments requires innovation beyond the traditional dance language. Chemical markers become more sophisticated, carrying complex messages across longer distances. Acoustic signals evolve to penetrate urban noise, while visual displays adapt to artificial lighting conditions. Food processing techniques advance to handle novel nectar sources and contaminated materials. Specialized workers develop the ability to detoxify marginally poisonous plants, expanding the range of usable flowers. Others learn to concentrate nutrients from diluted sources, maximizing energy return from poor quality forage. The honey produced by these adapted colonies reflects their changing world. Traditional monofloral honeys give way to complex blends that mirror the diverse urban and suburban environments where bees now forage. Some honeys contain trace compounds that would have been foreign to your palate, residues of human agriculture and industry that have become part of the bee's chemical landscape. Storage strategies evolve to handle irregular resource availability. Instead of simply stockpiling honey for winter, successful colonies maintain diverse reserves distributed across multiple cache sites. They learn to preserve pollen through new fermentation processes that extend shelf life and improve nutritional content. Nest defense becomes more sophisticated as threats multiply and diversify. Guard bees develop enhanced recognition systems that can distinguish between dozens of different danger types. Alarm pheromones become more specific, triggering appropriate responses to particular threats rather than general panic. Some colonies establish early warning networks with neighboring communities, sharing information about approaching dangers through chemical signals that travel between nests. These intercolony alliances represent a new level of social organization that transcends traditional territorial boundaries. The reproductive strategies pioneered in your time continue to evolve under modern pressures. Queens learn to adjust their egg-laying schedules based on environmental forecasts, timing reproduction to match predicted resource availability. They develop the ability to selectively activate different genetic programs in their offspring, producing workers with traits matched to current conditions. Mating flights become more complex as suitable partners become scarcer and more widely dispersed. Queens travel farther and stay airborne longer, sometimes joining temporary aggregations where multiple colonies coordinate their reproductive timing. These mating congregations represent new forms of genetic exchange that increase diversity while maintaining local adaptations. The winter survival strategies that kept your colony alive through harsh seasons prove inadequate for modern challenges. Colonies develop active winter behaviors, maintaining low-level foraging operations when weather permits. They learn to exploit artificial heat sources and sheltered microclimates that extend their active season. Some populations abandon winter dormancy entirely, maintaining year-round activity in urban heat islands and greenhouse environments. These perpetually active colonies face new stresses, but also gain competitive advantages building larger populations and exploiting resources unavailable to traditional seasonal cycles. The pollination services that justified your existence become even more critical as natural ecosystems fragment and agricultural systems intensify. Your descendants find themselves managing increasingly complex relationships with both wild plants and human crops. They develop specialized techniques for different plant families, maximizing pollination efficiency while minimizing energy expenditure. Some bee populations become so specialized that they can only survive in partnership with specific human agricultural practices. They time their life cycles to match crop flowering schedules and develop behavioral modifications that improve their effectiveness as agricultural workers. The boundary between wild and domesticated bees begins to blur, but wildness persists even in managed populations. Your descendants retain the independence and adaptability that characterized your own life, finding ways to thrive despite human interference. They exploit agricultural systems while maintaining their own agendas, building wild colonies in forgotten corners of managed landscapes. The genetic legacy you helped preserve continues to spread through increasingly complex networks of exchange. Modern bee populations represent unprecedented mixtures of traits from multiple ancestral sources, creating combinations of abilities that no historical population possessed. Your own genetic contributions become part of this vast gene pool, influencing bees in environments you could never have imagined. Research conducted by humans begins to reveal the extraordinary complexity of bee society and cognition. Scientists discover that bees possess mathematical abilities, emotional responses, and problem-solving skills that rival those of much larger animals. The intelligence that guided your own foraging decisions becomes recognized as part of a sophisticated biological computer distributed across thousands of individuals. This scientific understanding leads to new conservation strategies designed to protect bee populations and their ecological services. Protected habitats are established specifically for pollinators, while agricultural practices are modified to reduce harm to bee communities. The work you did visiting flowers gains recognition as an essential ecosystem service worthy of protection and support. Technology develops that can monitor individual bees throughout their lives, tracking their movements and behaviors with unprecedented precision. These studies reveal the remarkable consistency of bee behavior across different environments and time periods. The patterns of activity you followed during your brief life turn out to be fundamental features of bee biology that persist despite dramatic environmental changes. Artificial intelligence systems designed to understand bee behavior discover principles of organization that inspire new approaches to human problems. The decentralized decision-making that characterized your colony becomes a model for managing complex systems ranging from internet traffic to urban planning. Your collective intelligence influences human society in ways you could never have anticipated. But perhaps the most remarkable development is the growing recognition among humans that individual bees like yourself possessed rich inner lives worthy of respect and consideration. The consciousness that experienced your first flight, tasted your first flower, and felt satisfaction at a successful foraging trip becomes acknowledged as a genuine form of awareness, deserving moral consideration. This shift in perspective leads to new approaches to bee conservation that consider not just population numbers, but the quality of life experienced by individual bees. Habitat restoration projects focus on creating environments that support natural behaviors and social interactions. Agricultural practices are evaluated not just for their effects on bee survival, but for their impact on bee welfare and autonomy. Your brief existence, which seemed so small and insignificant at the time, becomes part of a larger story about the value of all conscious life. The dedication you showed to your colony, the skills you developed as a forager, and the sacrifices you made for future generations serve as examples of the remarkable capabilities present even in the smallest minds. The flowers you visited continue to bloom, now tended by bees whose abilities surpass anything your generation could achieve. But they carry forward the same essential drive that motivated your own efforts, the determination to gather resources, support their communities, and ensure the continuation of life. The work goes on, more complex than ever, but fundamentally unchanged. Your complete life as a worker bee becomes one thread in an enormous tapestry that connects past and future, individual and community, local action, and global consequence. Every flower you pollinated contributed to forests that now shelter new species. Every dance you performed shared knowledge that influenced countless foraging decisions. Every moment of your existence added something irreplaceable to the ongoing story of life on Earth. The legacy continues to unfold in ways beyond imagination, but the foundation remains the same. Individual lives lived with purpose and dedication, contributing to something greater than themselves. Your story ends, but the story it helped create goes on forever, as beautiful and complex as the dance language that once carried your discoveries back to the heart of the colony. The changing world brings new forms of competition that your ancestors never faced. Managed bee operations arrive in your territory, massive commercial hives transported by trucks containing populations that dwarf your wild colony. These industrial bees work with mechanical efficiency, their movements coordinated by human schedules rather than natural rhythms. When the truck-mounted hives arrive, they unleash tens of thousands of foragers into your carefully mapped territory. The flowers you've been visiting for weeks suddenly swarm with unfamiliar bees, their bodies marked with paint dots and numbered tags. They work faster than your colony ever could, stripping nectar from entire patches before your foragers even arrive. Your descendants adapt by shifting their schedules, foraging during times when the managed bees are less active. They learn to exploit resources the commercial operations ignore, small flowers that don't provide enough nectar for industrial-scale harvesting, plants that bloom outside the commercial season, hidden patches in areas too remote for truck access. But the competition is relentless. The managed bees are bred for productivity, their genetics optimized for maximum nectar collection and pollen gathering. They carry diseases your wild population has never encountered, pathogens that spread through shared flower visits and contaminated pollen stores. Your colony's natural immunity, developed over generations of local adaptation, proves inadequate against these foreign threats. Some wild colonies collapse entirely under the pressure. Others survive by becoming essentially feral versions of the managed stock, their genetic diversity reduced to whatever proves most competitive in the new environment. The unique local adaptations that took generations to develop disappear in a single season of overwhelming competition. Your genetic line persists by finding refuge in marginal habitats the commercial operations can't exploit. Small woodland clearings, urban rooftops, abandoned lots where wildflowers grow without human management. These become the strongholds where truly wild bees maintain their independence. It's a precarious existence, but it preserves something essential that would otherwise be lost. The flowers themselves begin to change in response to the altered pollination landscape. Plants that evolved in partnership with diverse wild bee communities now receive visits primarily from a few managed species. Their reproductive strategies shift to accommodate these new relationships, sometimes at the cost of compatibility with remaining wild populations. Some plants become dependent on the intensive pollination services provided by managed hives, producing larger crops but losing the ability to reproduce effectively with wild pollinators. Others evolve in the opposite direction, developing traits that specifically attract wild bees while deterring managed ones. The botanical landscape fractures into zones of human influence and wild persistence. Your descendants navigate this divided world with characteristic adaptability. They learn to recognize the difference between managed and wild flower patches, adjusting their behavior accordingly. In areas dominated by commercial operations, they become more aggressive competitors. In wild zones, they maintain the cooperative behaviors that sustained your original colony. New diseases emerge from the intersection of wild and managed populations. Viruses that cause minor symptoms in managed bees prove devastating to wild colonies that lack genetic resistance. Bacterial infections spread through shared flower visits, jumping between species barriers that once provided protection. Your immune system, which successfully defended against the pathogens of your time, would be helpless against these modern plagues. Yet some wild populations develop remarkable resistance to these new threats. Random genetic mutations that might have been neutral in your time become life-saving advantages in the modern environment. Colonies that survive the initial disease outbreaks often emerge stronger and more resilient than their ancestors ever were. The social structures that evolved in your colony prove surprisingly flexible when faced with these new challenges. Worker bees begin specializing in roles that didn't exist in your time. Disease scouts who can detect infected flowers, chemical analysts who can assess the safety of novel nectar sources, diplomats who negotiate resource-sharing agreements with neighboring colonies. Communication systems expand to handle the complex information needed for survival in a managed landscape. Dance languages develop new vocabulary to describe the locations and schedules of commercial operations. Chemical signals become more sophisticated, carrying warnings about contaminated areas and recommendations for alternative foraging sites. Some wild colonies develop almost parasitic relationships with managed operations, following the commercial hives to exploit their discoveries while avoiding direct competition. These shadowing behaviors require precise timing and detailed knowledge of commercial schedules, representing a new form of intelligence that your generation could never have imagined. The queens of modern wild colonies face decisions your queen never encountered. Should they time their reproduction to avoid peak commercial seasons? Should they relocate their entire operation when managed hives arrive? Should they attempt to interbreed with managed stock to acquire useful traits, even at the cost of genetic purity? Different colonies make different choices, creating a patchwork of survival strategies across the landscape. Some maintain strict isolation, preserving ancient genetic lineages at the cost of reduced competitiveness. Others embrace hybridization, trading genetic heritage for immediate survival advantages. Most find some middle ground, selectively incorporating useful traits while maintaining their essential wildness. The honey produced by these modern wild colonies tells the story of their struggle. Traditional floral sources are often overwhelmed by commercial operations, forcing wild bees to exploit marginal resources. Their honey becomes a complex mixture of minor flowers, urban weeds, and whatever surplus the managed bees leave behind. But this challenged honey often possesses unique properties that commercial honey lacks. The diverse minor flowers provide compounds that have been lost from simplified agricultural landscapes. The stress of competition and disease exposure triggers the productions of defensive chemicals that enhance the honey's medicinal properties. What seems like inferior production sometimes proves superior in unexpected ways. Storage strategies evolve to handle the uncertainty of modern foraging. Wild colonies can no longer count on predictable seasonal patterns or reliable resource availability. They develop more flexible approaches, maintaining multiple smaller caches rather than single large stores, and learning to process and preserve novel food sources that previous generations would have rejected. The architecture of wild nests adapts to new security requirements. Traditional nest sites become vulnerable to discovery and disruption by commercial operations. Wild colonies learn to build in more concealed locations, developing construction techniques that minimize their detection while maximizing their defensive capabilities. Some wild populations abandon fixed nests entirely, becoming truly nomadic societies that move constantly to avoid competition and exploitation. These wandering colonies represent the ultimate expression of bee adaptability, maintaining social cohesion while living essentially as aerial nomads. The pollination services provided by these surviving wild colonies become increasingly valuable as the limitations of managed systems become apparent. Commercial operations excel at crop pollination, but often fail to service the wild plants that maintain ecosystem stability. Wild bees fill this crucial gap, preserving botanical diversity that would otherwise collapse. This ecological role gains recognition among conservation biologists who begin studying wild bee populations with new appreciation. Research reveals that your descendants provide pollination services that can't be replicated by managed operations, visiting flowers that commercial bees ignore, transferring pollen between widely separated plant populations, maintaining genetic diversity in wild plant communities. Protected areas are established specifically to preserve wild bee habitat, creating refuges where natural selection can continue operating without commercial interference. These reserves become laboratories for studying bee evolution and behavior, revealing the remarkable diversity of adaptations that emerge when populations are allowed to develop independently. The genetic legacy you helped preserve becomes recognized as a crucial resource for future bee breeding programs. Wild populations maintain genetic variants that have been lost from managed stock, traits that might prove essential for adapting to future environmental changes. Your genetic contributions become part of a global effort to preserve bee diversity. Citizen science projects engage thousands of volunteers in monitoring wild bee populations, documenting their behaviors, and tracking their responses to environmental changes. The observations reveal that individual wild bees often display more complex and varied behaviors than their managed counterparts, retaining the behavioral flexibility that characterized your own life. Educational programs begin teaching children about the importance of wild bees and the threats they face. Young people learn to recognize different bee species and understand their ecological roles. Gardens are planted specifically to support wild bee populations, creating corridors of suitable habitat through otherwise hostile landscapes. Urban planning begins incorporating bee-friendly design principles, creating green spaces that can support wild colonies while providing human recreation areas. Rooftop gardens, park meadows, and roadside plantings are designed with native plants that bloom throughout the bee season, providing resources for wild populations year-round. Agricultural policies slowly begin shifting to support pollinator conservation alongside crop production. Farmers receive incentives to maintain wild habitat on their land and reduce pesticide use during bloom periods. Some agricultural areas are managed specifically to benefit wild bees, creating a mosaic of production and conservation zones. The research reveals that wild bee intelligence operates on principles fundamentally different from those governing managed populations. Wild bees show greater individual variation in behavior, more creative problem solving abilities, and stronger responses to environmental cues. The standardization that makes managed bees efficient also limits their adaptability. Your descendants demonstrate cognitive abilities that surprise even experienced researchers. They learn to anticipate human activities and adjust their foraging schedules accordingly. They develop social traditions that pass behavioral innovations between generations. They show emotional responses to environmental changes that suggest forms of consciousness previously unrecognized in insects. These discoveries lead to new ethical frameworks for thinking about human relationships with wild bee populations. The recognition that individual bees possess complex inner lives worthy of moral consideration begins influencing policy decisions about habitat protection and agricultural practices. Conservation genetics programs work to preserve the genetic diversity represented by wild bee populations. Tissue samples are collected and stored in genetic banks, preserving the evolutionary heritage that commercial breeding has narrowed. Some programs attempt to reintroduce genetic diversity into managed populations, crossing wild and commercial lines to create more resilient stock. The climate continues changing in ways that challenge both wild and managed bee populations. Temperature extremes become more frequent, disrupting the synchronized relationships between bees and flowers that took millions of years to evolve. Precipitation patterns shift dramatically, creating droughts and floods that devastate both natural and agricultural ecosystems. Your descendants face these challenges with the same determination that carried you through your own struggles. They adjust their behaviors to match new environmental rhythms, exploit novel resources as they become available, and maintain social cohesion despite increasing stress. The fundamental drive to survive and reproduce that motivated your life continues to power their efforts. New technologies emerge that can monitor wild bee populations in real time, tracking their movements and behaviors with unprecedented precision. These systems reveal the remarkable efficiency with which wild bees exploit their environments, often outperforming managed operations in terms of energy return on investment. The data shows that wild bees make decisions based on information integration that rivals sophisticated computer systems. They process environmental cues, evaluate resource quality, assess risk levels, and coordinate social activities using cognitive mechanisms that operate far faster than conscious thought. The intelligence that guided your foraging decisions represents just one example of computational abilities present throughout the natural world. Artificial intelligence researchers study wild bee behavior to understand principles of distributed decision-making and collective intelligence. The organizational strategies that emerged in your colony inspire new approaches to managing complex human systems, from traffic control to economic planning. But perhaps the most important recognition is that wild bee populations represent irreplaceable components of global ecosystems. The pollination services they provide, the genetic diversity they maintain, and the ecological relationships they support cannot be replaced by any human technology. Your descendants carry forward responsibilities that extend far beyond their individual survival. The flowers you once visited continue to depend on wild bee populations for their reproduction. The forests that provide oxygen, the meadows that prevent erosion, the wildlands that harbor biodiversity all rely on the pollination services that your genetic line continues to provide. The work you began with your first foraging flight echoes through ecosystems around the world. Your complete life as a worker bee becomes part of a story much larger than any individual could comprehend. The dedication you showed to your colony The skills you developed through trial and error, the sacrifices you made for future generations, all contribute to the ongoing survival of wild bee populations in an increasingly challenging world. The legacy continues in countless ways, through the flowers that bloom because your descendants pollinate them, through the ecosystems that persist because wild bees maintain their plant communities, through the genetic diversity that survives because wild populations preserve evolutionary heritage. Your brief existence helped sustain something that extends far beyond the boundaries of any single life. The world keeps changing, but your descendants find ways to survive that would amaze you. Some colonies develop partnerships with human beekeepers who understand the value of wild genetics. These relationships aren't the industrial operations that strip resources. They're collaborations where humans provide protection and supplemental feeding while bees maintain their natural behaviors and genetic independence. These cooperative colonies occupy a middle ground between truly wild and fully managed populations. They nest in human-provided hives, but forage according to their own schedules. They accept winter feeding when natural resources fail, but reject attempts to control their reproductive timing. It's a delicate balance that requires mutual respect and understanding. The beekeepers who work with wild colonies learn to read bee behavior with unprecedented subtlety. They recognize individual worker personalities, understand colony mood shifts, and respond to bee preferences rather than imposing human schedules. These partnerships demonstrate that cooperation between species is possible when humans abandon the desire for total control. Some wild colonies develop even more remarkable relationships with their environments. They learn to predict weather patterns days in advance, adjusting their activities based on atmospheric pressure changes and electromagnetic field fluctuations. Their forecasting abilities often surpass human meteorological systems, allowing them to avoid storms and exploit brief windows of favorable conditions. Urban wild colonies become particularly sophisticated in their environmental monitoring. They track air pollution levels through chemical sensors in their antennae, avoiding areas with dangerous contamination. They learn to navigate using artificial landmarks, creating mental maps that incorporate human architecture alongside natural features. City life transforms them into a new kind of bee, adapted to metropolitan survival. The communication systems these urban colonies develop become increasingly complex. They exchange information not just about flower locations, but about safe flight corridors, pollution levels, and human activity patterns. Their dance language expands to include warnings about construction zones, celebrations of newly discovered garden patches, and detailed descriptions of seasonal changes in urban microclimates. Some researchers begin studying these urban bee populations as models for sustainable city design. The efficiency with which wild bees exploit urban resources reveals opportunities for human communities to live more harmoniously with their environments. Bee flight paths inspire new approaches to transportation planning, while bee architecture influences building design principles. But the rural wild populations face different challenges as agricultural landscapes continue intensifying. Monoculture farming eliminates the diverse flower resources that sustained your colony, replacing them with vast fields of single crops that bloom all at once and then disappear. Your descendants must travel unprecedented distances to find adequate nutrition throughout the season. Some rural colonies develop seasonal migration patterns, following bloom cycles across hundreds of miles. These traveling populations maintain temporary nest sites at regular intervals, creating networks of way stations that support their nomadic lifestyle. It's an exhausting existence that pushes bee endurance to its limits, but it allows survival in landscapes that would otherwise be uninhabitable. The genetic diversity preserved in these far-ranging populations proves crucial for species survival. Genes that confer heat tolerance, cold resistance, disease immunity, and navigational ability get mixed and recombined across vast geographic ranges. Your genetic contributions spread through these traveling populations, influencing bees in ecosystems you never saw. Climate change accelerates, bringing challenges that test every adaptation your descendants have developed. Flowers bloom weeks earlier than historical patterns, disrupting the timing relationships that took generations to establish. Some plants shift their geographic ranges faster than bee populations can follow, creating mismatches between pollinators and their traditional food sources. Your descendants respond with behavioral flexibility that demonstrates the remarkable plasticity of bee intelligence. They learn to exploit new flower species as they become available, developing preferences for plants their ancestors never encountered. They adjust their seasonal schedules to match shifting bloom times, sometimes completing multiple generations per year when conditions permit. Temperature extremes become more frequent and severe, creating heat stress that challenges bee physiology. Your descendants develop new cooling behaviors, forming ventilation chains that move air through their nests more efficiently. They learn to time their flights to avoid the hottest parts of the day, shifting to dawn and dusk, foraging when midday temperatures become lethal. Water becomes a critical resource as droughts intensify across many regions. Wild colonies develop sophisticated water collection and storage systems, gathering moisture from dew, rain, and even humid air. Some colonies establish partnerships with other species, trading pollination services for access to water sources controlled by different animals. The social structures that evolved in your colony continue adapting to these new stresses. Worker roles become more fluid as environmental unpredictability demands greater flexibility. Bees switch between foraging, nursing, construction, and defense duties based on immediate colony needs rather than age-based schedules. Queens develop new reproductive strategies to cope with uncertain resource availability. Some learn to enter temporary dormancy during resource shortages, suspending egg production until conditions improve. Others increase their reproductive rate during favorable periods, producing multiple cohorts of workers to take advantage of brief abundance. Swarm timing becomes more opportunistic as traditional seasonal cues become unreliable. Colonies monitor environmental conditions continuously, sending out reproductive swarms whenever a combination of factors suggests good prospects for establishment. This flexibility allows rapid colonization of newly suitable habitats while avoiding predictable resource crashes. The architecture of wild nests evolves to handle more extreme weather conditions. Colonies build thicker insulation, create better drainage systems, and design structural reinforcements that can withstand severe storms. Some develop modular construction techniques that allow rapid rebuilding after damage. Nest site selection becomes more strategic as suitable locations become scarcer. Wild colonies learn to evaluate potential sites based on long-term climate projections rather than current conditions. They seek locations with thermal stability, protection from extreme weather, and proximity to diverse food sources that might persist through environmental changes. The foraging strategies that guided your daily flights continue evolving under new pressures. Modern wild bees develop more sophisticated risk assessment abilities, evaluating flower patches for pesticide contamination, disease exposure, and competition intensity. They learn to recognize subtle signs of plant stress that indicate poor nectar quality. Energy management becomes crucial as foraging distances increase and resource quality declines. Wild bees develop more efficient flight patterns, optimizing their routes to minimize energy expenditure while maximizing resource collection. They learn to assess the energy value of potential food sources before committing to long flights. Pollen collection techniques adapt to handle new plant species and changing flower structures. Some flowers evolve different shapes or nectar compositions in response to climate change, requiring bees to modify their foraging behaviors. Your descendants develop new approaches to accessing these altered resources. The seasonal preparation strategies that kept your colony alive through winter become more complex as weather patterns become less predictable. Wild colonies maintain larger reserves to handle longer periods of resource scarcity. They develop better food preservation techniques to prevent spoilage during extended storage periods. Some populations abandon traditional overwintering strategies entirely, maintaining active colonies year-round in regions where climate change has eliminated freezing temperatures. These perpetually active colonies face new challenges, but also gain competitive advantages, building larger populations and exploiting resources unavailable to seasonally dormant competitors. The pollination services your descendants provide become even more critical as natural ecosystems fragment under environmental pressure. Wild plant populations become increasingly dependent on bee pollination for reproduction, especially as other pollinator species decline. Your genetic line carries responsibility for maintaining botanical diversity across entire regions. Agricultural systems begin recognizing the irreplaceable value of wild bee pollination services. Crops that once relied entirely on managed bees now depend on wild populations for genetic diversity and reproductive success. Farmers implement conservation practices specifically designed to support wild bee populations. Research reveals that wild bee pollination often produces higher quality seeds and fruits than managed bee pollination. The behavioral differences between wild and managed bees result in more thorough pollen transfer and better genetic mixing in plant populations. Your descendants provide services that cannot be replicated by any artificial system. Conservation programs expand to protect wild bee habitat on a landscape scale. Corridors of native plants connect fragmented wild areas, allowing bee populations to move between resource patches. These green corridors become lifelines for wild colonies struggling to survive in increasingly developed landscapes. Educational initiatives teach people to recognize and support wild bee populations in their local areas. Home gardens are planted with native flowers that bloom throughout the bee season. Pesticide use decreases as people understand the connection between chemical applications and bee population declines. Policy changes begin protecting wild bee habitat through legal mechanisms. Environmental impact assessments must consider effects on wild pollinator populations. Development projects are required to include pollinator-friendly landscaping. Agricultural subsidies are tied to conservation practices that benefit wild bees. The genetic resources preserved in wild bee populations become recognized as global treasures worthy of international protection. Genetic sampling programs document the diversity present in wild populations before it can be lost. Some extinct wild bee genes are recovered from museum specimens and reintroduced into surviving populations. Breeding programs work to incorporate wild bee genetics into managed populations, improving their disease resistance and environmental adaptability. These efforts require careful balance to avoid overwhelming wild gene pools with managed bee characteristics while still preserving valuable wild traits. Climate adaptation research focuses on identifying wild bee populations with traits that might prove valuable under future environmental conditions. Colonies that survive in extreme environments are studied intensively to understand their adaptive mechanisms. This knowledge guides conservation efforts and breeding programs. The intelligence that guided your foraging decisions continues to fascinate researchers studying animal cognition. Wild bees demonstrate problem solving abilities, learning capabilities, and social coordination skills that rival much larger animals. Your cognitive abilities represent just one example of the remarkable intelligence present in small brained creatures. Neuroscience research reveals that bee brains operate on computational principles that could inspire new artificial intelligence systems. The efficiency with which bees process environmental information and make decisions offers insights into optimal information processing strategies. But beyond their practical value, wild bee populations gain recognition for their intrinsic worth as conscious beings deserving of moral consideration. The experiences you had during your brief life, the satisfaction of successful foraging, the social bonds with nestmates, the drive to contribute to colony survival, are acknowledged as genuine forms of consciousness worthy of respect. This ethical recognition influences conservation policy and agricultural practice. Decisions about land use and chemical applications are evaluated not just for their effects on bee populations, but for their impact on individual bee welfare. The quality of life experienced by wild bees becomes a legitimate consideration in environmental planning. Your complete life as a worker bee becomes part of a larger story about the value of wildness itself. The genetic diversity, behavioral flexibility, and ecological relationships preserved in wild bee populations represent irreplaceable components of Earth's biological heritage. Your descendants carry forward evolutionary wisdom accumulated over millions of years. The flowers you visited during your brief foraging career continue to bloom, now pollinated by bees whose abilities have been shaped by generations of environmental challenge and adaptation. Each flower they visit, each grain of pollen they transfer, each seed they help create contributes to the ongoing story of life's persistence and creativity. The work you began with your first tentative flight outside the nest continues in forms you could never have imagined. Your genetic legacy spreads through populations that span continents, influences species interactions across entire ecosystems, and contributes to the resilience that allows life to persist through environmental upheaval. The cycle of seasons that marked your brief existence continues its ancient rhythm, though altered by human influence and climate change. Spring still brings the explosion of flowers that calls forth new generations of bees. Summer still provides the abundance that fuels colony growth. Autumn still triggers the preparations that ensure winter survival. But now these seasonal cycles carry forward the accumulated wisdom of countless generations of wild bees who faced and overcame environmental challenges. Your descendants inherit not just genetic material, but behavioral traditions, environmental knowledge, and social innovations that improve their chances of survival. The story that began with your hatching from a tiny egg continues to unfold across landscapes and through generations. Each bee that emerges from her cell takes her first flight and begins the work of foraging carries forward something essential that you helped preserve. The dedication you showed to your colony, the skills you developed through experience, the sacrifices you made for future generations echo through time. Your complete life as a worker bee represents one thread in an enormous tapestry of existence that connects all living things. The flowers you pollinated influenced the composition of plant communities. The genes you carried contributed to the diversity that allows species to adapt and survive. The behaviors you exhibited added to the collective knowledge that guides bee societies. The nest you helped build may have crumbled long ago, but its influence persists in the architectural innovations your descendants employ. The dances you performed to share information about flower locations contributed to communication systems that continue evolving. The routes you discovered through trial and error became part of the landscape knowledge that wild bee populations use to navigate their territories. In the end, your life as a worker bee achieved exactly what evolution designed it to achieve. You contributed to something larger than yourself, helped ensure the survival of your genetic line, and played your part in the complex web of relationships that sustains life on Earth. Your individual consciousness may have ended, but your influence continues rippling forward through time, touching lives and ecosystems in ways that extend far beyond the boundaries of any single existence. The morning sun that called you to your final foraging flight continues to rise over fields where your descendants work. The flowers that provided your sustenance continue to bloom, supported by the pollination services your genetic line provides. The great work of life continues, more complex and challenging than ever, but sustained by the same fundamental drives that motivated your dedication to colony and species. Your story ends where all bee stories must end, but the larger story it helped create goes on. In every flower that blooms, every seed that forms, every new bee that emerges to take up the work of foraging and pollination, something of your brief but meaningful existence continues. The cycle is eternal, the work is endless, and the beauty of it all lies in the dedication of individuals like yourself who give everything they have to ensure that life continues. Winter arrives earlier than expected, and your descendants face their greatest test yet. The colony huddles together as temperatures plummet, their bodies generating just enough heat to keep the queen alive at the center of the cluster. Workers on the outside of the formation sacrifice themselves to insulate their sisters, their life force slowly ebbing as they shield the colony from the killing cold. Food stores run dangerously low as the harsh season stretches longer than anyone anticipated. The honey that should have lasted until spring dwindles to critical levels. Workers make impossible decisions: feed the developing brood or preserve resources for the adults who must survive to care for them. Some larvae are sacrificed, their protein recycled to sustain the workers who might live to see another season. But this winter brings more than just cold and hunger. A new pathogen spreads through bee populations across the continent, carried by mites that burrow into developing pupae. The disease has no name and no cure. It simply appears one day, turning healthy colonies into ghost towns within weeks. Your descendants watch neighboring nests fall silent, their entrance holes dark and lifeless. The pathogen reaches your genetic line through a forager who unknowingly carries infected mites back from a contaminated flower patch. Within days, workers begin showing symptoms: disorientation, trembling wings, and inability to navigate back to the nest. They stumble through the air like broken machines, their sophisticated navigation systems scrambled by viral interference. Some colonies collapse entirely, their populations crashing as the disease spreads through the crowded winter cluster, but others discover an unexpected defense. Workers with certain genetic variants, random mutations that seemed meaningless in healthier times, prove resistant to the pathogen. Your genetic contributions include some of these protective sequences, passed down through generations, and now revealed as life-saving adaptations. The surviving colonies emerge from winter fundamentally changed. Their populations are smaller, their genetic diversity reduced, but they carry resistance to threats that devastated their neighbors. The random genetic recombination that created your own unique genome continues to generate new combinations, some of which prove crucial for survival in an increasingly hostile world. Spring arrives with unusual weather patterns that confuse both bees and flowers. Plants bloom weeks earlier than normal, then face late freezes that destroy their reproductive structures. Some species skip blooming entirely, their internal clocks disrupted by erratic temperature swings. Your descendants adapt by becoming more opportunistic, exploiting whatever resources become available, regardless of traditional seasonal expectations. The early spring chaos creates unexpected opportunities alongside the obvious challenges. Weedy plants that once provided marginal nutrition become primary food sources when traditional flowers fail. Urban heat islands create microclimates where some plants continue blooming through weather that would normally end their season. So, wild colonies learn to exploit these artificial environments with characteristic ingenuity. Foraging strategies evolve rapidly under these new pressures. Scouts range farther than ever before, sometimes traveling miles to find adequate resources. They develop new communication techniques to describe distant food sources, their dance language expanding to handle the complex navigation required for long-distance foraging. Information sharing becomes even more critical as resources become scarcer and more unpredictable. The queen's egg-laying schedule adapts to match the erratic resource availability. Instead of following traditional seasonal patterns, she responds to immediate environmental cues, laying more eggs when food is abundant, reducing production during shortages. This flexibility requires constant communication between foragers and nurses, creating feedback loops that weren't necessary in more stable times. Colony defense mechanisms become more sophisticated as competition intensifies. Wild colonies develop better early warning systems, posting sentries that can detect approaching threats from greater distances. They learn to recognize the chemical signatures of different competitor species and adjust their defensive strategies accordingly. Some colonies form temporary alliances with neighbors, sharing information about threats and resources. The social structure that governed your original colony continues evolving under these new pressures. Worker specialization becomes more fluid as unpredictable conditions demand rapid role changes. Bees learn to switch between foraging, nursing, construction, and defense based on immediate colony needs rather than predetermined age-based progressions. This flexibility improves survival, but requires more complex coordination systems. Communication networks extend beyond individual colonies, as information sharing becomes crucial for regional survival. Chemical signals carry news about resource discoveries, disease outbreaks, and environmental hazards across networks of neighboring nests. These inter-colony communication systems represent new levels of social organization that transcend traditional territorial boundaries. Some wild populations develop nomadic lifestyles, abandoning fixed nest sites in favor of portable communities that can relocate as conditions change. These wandering colonies face constant challenges, but also gain access to resources unavailable to stationary populations. They develop specialized construction techniques that allow rapid nest establishment and abandonment. The architecture of permanent nests adapts to handle more extreme environmental conditions. Colonies build more sophisticated ventilation systems to manage temperature fluctuations. They create better drainage to handle increased precipitation. Some develop modular construction techniques that allow sections of the nest to be sealed off during emergencies. Storage strategies become more complex as resource availability becomes increasingly unpredictable. Wild colonies maintain multiple smaller caches distributed across their territory rather than single large stores. They develop better food preservation techniques to prevent spoilage during extended storage periods. Some learn to process and store novel food sources that previous generations would have rejected. The honey produced by these adapted colonies reflects their changing world. Traditional single flower honeys give way to complex blends that mirror the diverse and often marginal resources wild bees now exploit. Some honeys contain defensive compounds produced by stressed plants, creating products with enhanced antimicrobial properties. Reproductive timing becomes more opportunistic as traditional seasonal cues become unreliable. Queens learn to recognize environmental windows that favor successful mating and colony establishment, regardless of calendar timing. Some populations produce multiple swarms per season when conditions permit, while others skip reproduction entirely during unfavorable years. Mating flights adapt to new environmental realities as suitable partners become scarcer and more widely dispersed. Queens travel farther and coordinate their reproductive timing through chemical signals that span greater distances. Some develop the ability to delay egg development until environmental conditions improve, extending their reproductive potential across longer time periods. The genetic diversity preserved in wild populations becomes increasingly valuable as environmental stresses intensify. Traits that seemed neutral in stable conditions prove crucial for survival under new pressures. Heat tolerance, disease resistance, behavioral flexibility, and nutritional adaptability all become essential characteristics that determine which colonies survive and which disappear. Conservation genetics programs recognize the irreplaceable value of wild bee genetic resources. Tissue samples are collected and preserved in cryogenic storage, maintaining genetic libraries that could prove crucial for future restoration efforts. Some programs attempt to reintroduce lost genetic variants into surviving populations, carefully balancing genetic diversity with local adaptation. Research reveals that wild bee populations possess cognitive abilities far more sophisticated than previously recognized. They demonstrate abstract thinking, emotional responses, and social learning capabilities that rival much larger animals. The intelligence that guided your own foraging decisions represents just one example of the remarkable mental capabilities present throughout the bee world. Artificial intelligence researchers study wild bee behavior to understand principles of distributed decision-making and swarm intelligence. The organizational strategies that emerged in your colony inspire new approaches to managing complex systems ranging from robotics to urban planning. Your collective intelligence influences human technology in ways you could never have anticipated. But perhaps the most significant development is the growing recognition that individual wild bees possess intrinsic value worthy of moral consideration. The consciousness that experienced your first flight, felt satisfaction at successful foraging, and drove your dedication to colony survival becomes acknowledged as a genuine form of awareness, deserving respect and protection. This ethical recognition influences conservation policy and environmental management. Decisions about land use, chemical applications, and habitat modification are evaluated not just for their effects on bee populations, but for their impact on individual bee welfare. The quality of life experienced by wild bees becomes a legitimate factor in environmental planning. Educational programs teach people to recognize and appreciate the complexity of wild bee societies. Children learn to observe bee behavior with new understanding, recognizing the intelligence and purpose behind activities that might once have seemed purely mechanical. This deeper appreciation fosters conservation attitudes that support wild bee protection. Urban planning begins incorporating bee-friendly design principles that create habitat corridors through developed landscapes, green roofs, pollinator gardens, and native plant landscaping provide resources for wild bee populations while enhancing human environments. Cities become partners in bee conservation rather than barriers to survival. Agricultural practices slowly shift to support wild bee populations alongside crop production. Farmers maintain hedgerows and field margins planted with native flowers that bloom throughout the bee season. Pesticide applications are timed to minimize impacts on bee populations, and some farmers adopt organic practices specifically to support pollinator health. The pollination services provided by wild bee populations gain recognition as essential ecosystem functions that cannot be replaced by managed systems. Wild bees service plant communities that managed operations ignore, maintaining botanical diversity crucial for ecosystem stability. Their work supports food webs that extend far beyond the immediate bee-flower relationships. Climate adaptation research focuses on identifying wild bee populations with traits that might prove valuable under future environmental conditions. Colonies that survive in extreme environments are studied to understand their adaptive mechanisms. This knowledge guides both conservation efforts and breeding programs designed to improve managed bee resilience. International cooperation develops around wild bee conservation, as scientists recognize that bee populations migrate across political boundaries and that genetic resources must be preserved on a global scale. Collaborative research programs share information about successful conservation strategies and coordinate efforts to protect critical habitats. Technology advances to the point where individual wild bees can be monitored throughout their entire lives, revealing the remarkable consistency of bee behavior across different environments and time periods. These studies confirm that the patterns of activity you followed during your brief life represent fundamental features of bee biology that persist despite dramatic environmental changes. The data reveals that wild bees make decisions based on information processing that rivals sophisticated computer systems. They integrate environmental cues, evaluate resource quality, assess risk levels, and coordinate social activities using cognitive mechanisms that operate faster than conscious thought. Your decision-making abilities represent part of a biological computational system of extraordinary sophistication. Neuroscience research uncovers the mechanisms underlying bee intelligence, revealing that their small brains achieve remarkable efficiency through specialized neural architectures. The cognitive abilities that guided your foraging flights operate on principles that inspire new approaches to artificial intelligence and robotic control systems. But beyond their practical applications, wild bee populations represent something irreplaceable, living repositories of evolutionary wisdom accumulated over millions of years. The genetic diversity, behavioral traditions, and ecological relationships they maintain cannot be recreated if lost. Your descendants carry forward biological heritage that took eons to develop. The flowers you visited during your brief career continue to bloom, now pollinated by bees whose abilities have been shaped by generations of environmental challenge and adaptation. Each flower they visit, each grain of pollen they transfer, each seed they help create contributes to the ongoing story of life's persistence and creativity in the face of constant change. Your genetic legacy spreads through populations that span continents, influences species interactions across entire ecosystems, and contributes to the resilience that allows life to persist through environmental upheaval. The traits you carried, your navigation skills, your flower preferences, your work ethic, continue to influence bee behavior in environments you could never have imagined. The nest you helped build may have crumbled long ago, but its influence persists in the architectural innovations your descendants employ. The dances you performed to communicate flower locations contributed to information systems that continue evolving to handle increasingly complex environmental data. The routes you discovered through patient exploration became part of the landscape knowledge that guides wild bee navigation. The social bonds that sustained your colony continue to evolve and adapt, finding new expressions in each generation. The cooperative spirit that defined your relationship with nestmates now manifests in inter-colony alliances, human bee partnerships, and conservation collaborations that span species boundaries. Your dedication to something larger than yourself echoes through expanding networks of mutual support. The seasonal rhythms that marked your existence continue their ancient patterns, though altered by human influence and climate change. Spring still brings renewal and the opportunity for new colonies to establish themselves. Summer still provides the abundance that fuels population growth. Autumn still triggers the preparations necessary for survival through harsh seasons. But now these natural cycles carry forward the accumulated wisdom of countless generations of wild bees who faced and overcame unprecedented challenges. Your descendants inherit not just genetic material, but behavioral traditions, environmental knowledge, and social innovations that improve their prospects for survival in an uncertain world. The morning light that called you to your first foraging flight continues to illuminate landscapes where your genetic descendants pursue their essential work. The flowers that sustained you continue to bloom, supported by pollination services that your lineage helps provide. The great dance of life continues, more complex and challenging than ever, but sustained by the same fundamental drives that motivated your brief but meaningful existence. Your complete life as a worker bee becomes part of an enormous story about the value of individual dedication in service of collective survival. The work you performed, the knowledge you gained, the sacrifices you made, all contributed to something that extends far beyond the boundaries of any single existence. Your legacy lives on in every flower that blooms, every seed that forms, every new bee that emerges to continue the ancient work of maintaining life's incredible diversity and resilience. The story reaches its natural conclusion as countless seasons have passed since your brief existence, but the impact of your life ripples forward through time in ways both subtle and profound. Your genetic code has traveled through thousands of generations, spreading across continents and adapting to environments that would have been unimaginable during your lifetime. The traits that made you successful, your precise navigation skills, your efficient foraging techniques, your unwavering dedication to the colony, continue to influence bee behavior in ecosystems around the globe. The flowers you once visited with such determination have evolved alongside your descendants, their relationships becoming more sophisticated and interdependent with each passing generation. Some plants have developed chemical signals specifically designed to attract the genetic lineages that trace back to your original colony. Others have adjusted their blooming schedules to match the foraging patterns that you and your sisters established generations ago. The partnership between bees and flowers that you participated in during your brief life has grown into something far more complex and beautiful than either species could have achieved alone. Modern wild bee colonies face challenges that dwarf anything you encountered, yet they survive and thrive using principles of cooperation and adaptation that were first tested in nests like yours. They've learned to navigate urban landscapes, exploit new food sources, resist novel diseases, and adapt to climate patterns that shift faster than any species has previously experienced. The resilience they demonstrate, traces back to the same fundamental drives that motivated your daily flights: the determination to gather resources, support the community, and ensure the continuation of life. The scientific understanding of bee intelligence has expanded dramatically since your time, revealing that the cognitive abilities you possessed represent just a glimpse of the remarkable mental capabilities present throughout the insect world. Researchers now recognize that the decisions you made during foraging flights involved complex calculations that rival sophisticated computer algorithms. Your ability to remember flower locations, optimize flight paths, and communicate discoveries to nestmates demonstrates information processing capabilities that continue to inspire advances in artificial intelligence and robotics. But beyond their practical applications, your descendants have gained recognition for something even more significant: their intrinsic value as conscious beings whose experiences matter in their own right. The satisfaction you felt when discovering a rich patch of flowers, the social bonds you formed with nestmates, the sense of purpose that drove your tireless work. These are now understood as genuine forms of consciousness worthy of respect and moral consideration. Conservation efforts worldwide now focus not just on maintaining bee populations, but on preserving the quality of life that individual bees experience. Protected habitats are designed to support natural behaviors and social interactions. Agricultural practices are evaluated for their impact on bee welfare as well as survival. Urban planning incorporates bee-friendly features that allow wild populations to thrive alongside human communities. Your brief but meaningful existence has become part of a larger recognition that every conscious life, no matter how small, contributes something irreplaceable to the magnificent tapestry of existence. The work you began with your first tentative flight outside the nest continues today in forms that span the globe. Every morning, millions of your genetic descendants emerge from their colonies to begin the ancient task of gathering nectar and pollen. They carry forward the same dedication that characterized your life, the same willingness to sacrifice for something greater than themselves, the same essential drive to ensure that life continues in all its incredible diversity and beauty. Your complete life as a worker bee represents one perfect example of how individual existence gains meaning through contribution to something larger and more enduring. The flowers you pollinated, the knowledge you shared, the genes you carried forward, all continue to influence the world in ways that extend far beyond the brief weeks of your existence. In the end, your story becomes part of the eternal story of life itself, a testament to the power of dedication, cooperation, and the endless creativity that emerges when countless individuals work together toward a common purpose. The cycle continues, as it always has and always will, with each new generation building upon the foundation laid by those who came before. Your legacy lives on in every flower that blooms, every seed that forms, every young bee that takes her first flight into a world full of possibilities. The great work goes on, and somewhere in that continuing story, the brief but beautiful life you lived as a worker bee remains forever woven into the magnificent complexity of existence itself. I hope you liked the video. Here you can find the next one. Until then, see you soon.